Hello, class. This is Professor Globe. We're on week 14, my last recorded lecture, our last lecture for the semester. Let me pull the slide deck up. All right. Get this up and running here. We all could hear me okay. Again, Professor Globe. CYBR 306 Information Security. We're in week 14 lecture. Topics for today are cloud migration methodologies and cloud security. Let's get started. So your cloud migration strategies, I've kind of talked about. I went over them at a high level in week 1, kind of like your core foundations. But basically, a lot of organizations, when they're trying to make a determination, should they move some of their applications from on-premise to a cloud provider like AWS or Amazon or Google Cloud. The decision they have to make is, do we want to just take our existing application and rehost them on virtual servers and endpoints using virtual networking equipment? As you can see here from the diagram, that takes less effort, less skill, less resources. It's much quicker, more cost effective. But you're not using any native cloud services or native cloud architecture. So therefore, it's not the most scalable, and could be, in the long term, not the best approach. The next kind of consideration or strategy is you revise some of your applications, and maybe you don't migrate, let's say, like your customer relation or any of your HR systems. You use native um, software as a service offerings that are equivalent. So you rehost some and revise some. Again, that require you to know a little bit more about deploying those types of software as a service in a cloud environment. So your skill set needs to go up, may require different resources from the cloud provider, may take a little bit more time to get it deployed correctly, get the security in place, etc. But longer term, it's much more scalable, maintainable to do it that way. Your next approach, which is definitely more expensive, requires more skill set, is a re-architect, where you really take advantage of the cloud environment. Some of this involves really taking a whole different approach to your current architecture, which may be like a monolith, a big legacy server, and all your applications are running on that legacy server, or clouds, um, client server architecture. Even if it's a web-based front end, it still could be almost, a monolith in the sense that all the applications are running on your web server. And you may want to re-architect that to use microservices, microsegmentation, those types of things. Those type of strategies, because your application is going to be more data-driven. That requires definitely more skills, resources from the cloud provider, increases the complexity, etc. So that's a re-architecture of same functionality, so to speak, in most cases. Or you can go with a rebuild of the same functionality again. Or you can do the replace. The replace is almost like a buy versus build, similar back to the revise that I talked about earlier. They're almost at the same level. Revise could be much more of a hybrid approach, and your replace could be really your buy versus build approach, where you buy the software as a service versus rehosting it or re-architecting or rebuilding it in the cloud. Requires less skill, but still you got to understand cloud environments, cloud resources, the cost model that you're going to be using there. And the replace could take longer because you may phase it in. Um, the service offering that you buy may cost a little bit more. Um, again, depends on the pricing model. So those are kind of like migration strategies. Next, you get into cloud security. Once you decide you are going to deploy some applications and use some virtual environments, virtual spaces, you got to know what to secure, what's your responsibility as an organization versus the cloud provider's responsibility. So that means you need to understand your virtual space, your virtual private cloud that you're purchasing. Understand access control in the cloud, still like access control in the traditional sense. How to assure your data is secure, so confidentiality, integrity, availability, all that comes into play there, even in a virtual environment. Understanding how to secure your virtual endpoints. Um, and then the data privacy piece of it too. You own your data, even if you decide to do the replace where you're going buy versus bill, make sure you read the terms and conditions of the service provider to know the data requirements, data retention. Um, when you're ready to stop using that service, the data purging requirements. So cloud security also involves compliance, which is following industry-specific rules and regulations. So many of the cloud providers have more secure environments, especially for federal and government agencies. They have a FedGov um, version of their public offering, which would use US only cleared personnel in some cases, which is a requirement of the federal government or some government agencies. In addition, cloud providers can only retain and process data on US soil. That's another kind of requirement. So knowing what your organization's requirements are upfront will help you make appropriate decisions on how to secure the data and really how much it's going to cost. So there, as we talked about in lecture, I think it was one, there are three main deployment strategies using cloud environments. There's infrastructure as a service, where you basically lease or rent not only your networking equipment, like your routers and switches, but you can even list your operating systems, your enterprise services, such as enterprise database. You could purchase your domain controllers from the cloud provider. So that's infrastructure as a service. These are more, kind of IT-like functions. Then you have platform as a service and software as a service. Platform as a service is typically where the software development organization will come in and they would develop, they would lease CPU or servers, memory, disk space, and they would install a development environment and they would build their platform. And they would then deploy that as software as a service, which is the last main configuration. And therefore, cloud security engineers, implementers, security personnel, they're all involved in your IT are all involved in these type of decisions of what your deployment strategies are, what you're going to deploy in those environments, what version of operating systems, et cetera, what domain controller service you're going to use, how are you going to assure confidentiality, integrity, and availability of those systems and the data being processed on those systems. So what is cloud security? It is all about protecting data stored in cloud computing environments to include, access control, encryption through VPN services. That's from virtual to virtual, or virtual to traditional systems, or virtual to external systems. Having firewalls in place, um, making sure that you pen test your virtual applications and virtual software is also important. So that's cloud security. It can be complex because you could be that you need to secure both your virtual environment or assets you have in the virtual environment and um, assets you have on-prem. Um, and so that would make things definitely much more complicated. I showed this table before in again previous lecture, but this kind of outlines who is responsible for what part based on your deployment strategy. So on the on-premise, an organization is responsible for data classification, accountability, in all endpoints, securing them, and securing your network, identity and access management, application security, operating systems, and physical security, the actual where the servers are at on site in the organization. Infrastructure as a service, as you can see here, the customer still bears 95% of the responsibility minus the physical. There are a few areas where it's shared, such as network controls and protections and operating system. But still, the primary um, entity that's responsible are the customers for their environment or for what they lease from the cloud provider. Then there's platform and software as a service. Those two are very similar. You see there are some areas where there's shared responsibility. The same thing holds true. Um, Even though your network controllers and protections, the rules that you want to enforce, you're responsible for that. You have to upload those rules. If you want to have a web application firewall, that's considered application level security, which is all customer, even though you may be using the cloud provider's firewall. So um, know this information. Definitely, I'll be asking you questions on it. So, security and risk management is definitely the focus for cybersecurity professionals when deploying applications to a cloud environment. They start by defining your cloud migration strategy, your cloud security strategy, and how you're going to go about uh, enforcing confidentiality, data integrity, and availability of those systems. Establish a cloud security architecture. Usually that's a defined role, making sure that you have someone on the team that is experienced in cloud architecture, cloud deployment strategies, cloud security strategies. And they'll discuss things like, should we have a cloud access security broker, which kind of sits in front of your, um, um, at the edge or at the perimeter of your cloud environment, and it acts as like a firewall almost in the sense it says, yes, you can come in and get access to these services, or no, no, you can't. So that's your CASB is what they call it for short. CASB uses protect sensitive data in a approved cloud apps for usage by users or other applications. It is policy driven, so that means it definitely can be managed and scaled through policy updates. Um, CASB helps you improve your control and confidentiality and integrity enforcement in your IaaS and PaaS environments. Where the reason why that's important because in your platform as a service, you may have sensitive data that you're doing development in an environment. You may have IP, so making sure you have the right access control, role-based, least privileges concepts is really, really important. This infograph comes from Gardner, kind of gives you the kind of like your layered approach to um, access control and securing and protecting your assets, whether across the different deployment strategies, whether it's infrastructure as a service, platform, or software as a service. You need to, um, identify and provide access control to your people as they go into the cloud environments, as you utilize your cloud providers' native services, whether it's Office 365 or Google Workspace, providing access control to that. You can see what your basic security is in your cloud environment, which is, just like on a native environment, uniquely identify each person coming into your domain, and making sure you have some factors of authentication to authenticate them, which will require, having a cloud security architecture, um, enforcing role-based access control. None of those things go away. But you get into maybe a different name, but still the same concept of how you would go about securing your cloud environment. Um, and whether that's you're going to use, software-defined microsegmentation, policy-driven access control and authorization. All those things still are important and matters in your cloud environment. So dedicated private clouds, they are hosted within a customer-owned, paid or lease virtual private area or instance, which is made up of, you know, CPU or processing um, assets and storage. And the networking piece that allows you to move data between endpoints. Community private clouds, these are located at the premises of third party, owned and managed and operated by a vendor, which is usually um, contractual through some service level agreements on availability and access and CPU speed. Or you can have a managed private cloud also. And you can see more of these where organizations are basically going to stand up their own cloud environment versus doing it on-prem. And they could, can turn it around to make money. They can lease out CPUs at off times to small businesses or nonprofits or something like that. But you will see more managed private clouds. I see a lot of former IT disaster recovery sites standing up their own private cloud and leasing it out to the local community or local small businesses in a city like Albany. Some other kind of security frameworks that are specific to your cloud environment. Some of these are, specific to Gartner, what they call them, and different vendors call them something slightly different. So you can adopt a secure access, secure edge. This is like zero trust. This is a concept, not a product. So this is, conceptually you design distributed and um, cloud controls in your environment. And basically this says no matter where you're at and where you connect to the network or the public network and then get access to the cloud environment, you will be authenticated and authorized to access. So, and it doesn't matter if you're on a company device or your own personal device. So secure access, secure the edge. And that means that there's some form of end-to-end virtual private encryption happening also. Then you get into your mesh architecture, which is basically a distributed or segmented architecture. So, you know, I think the best way to think of this is basically least privileges, policy-driven orchestration or automation. And what all that says is you need to enforce confidentiality, so access control. You need to enforce data integrity, again, access and authorization control, which means least privileges, no elevated permissions, and then assure that the data is available when your customers need it. So that's your mesh architecture. And it's similar to micro-segmentation, again, another big word, but basically if you isolate the HR department and the HR applications to the HR staff and give them access. That means you don't have to give engineering access or sales access to the HR area. That's mesh architecture basically. Um, Again, I've already kind of talked about this. Confidentiality is still really important, so that gets down to access control. And there's many services and concepts out there that helps you enforce access control in a virtual environment. And the reason why there's new ways of doing it is because these environments can get complex because you can have a mixture of virtual and on-premise. You can be using different virtual providers that may call their service something slightly different. And a big example of that is, your domain controllers. So many people use Microsoft um, um, domains on premise, and so they still want to use that. They don't want to have to go to something new, like on a Linux system or with Google. So they go to Azure for their domain services, but they may use Google Private Cloud. But all their users have an account in the Azure um, directory services. Other key best practices in this area of securing your deployment strategies would be, assessing your risk. So that means you knowing what assets you're going to be deploying in those environments. Doing configuration management, which means you need to baseline and have a change control process. Key parts there is, simple things as knowing what version of operating system you're going to deploy, or how often you're going to patch things, what's the patch level, what versions of other applications you're going to be deploying. Make sure you have logging turned on so you can audit, and then you parse those logs for looking for potential malicious activity. You still have to do vulnerability management, and you still want to do separation of duties. Other security options, you still have to account for in your virtual deployments is network security. Don't forget that. So even if it's a web application firewall, you still need to deploy things like that. Routers, your network perimeter firewall, switches, all those things, segmenting your network, all still important. Still having multi-factor authentication with zero trust concepts. Still need that in the cloud environment. Still need data loss prevention monitoring the virtual endpoints to prevent insider threat and other potential leakage of sensitive or confidential data. Still need encryption. We talked about that. Still need a business continuity and disaster recovery plan that encompasses your virtual assets, web security, email security. All those things still are important in a virtual environment. Other things to consider is the types of threats. Um, the types of threats that can happen in your traditional IT ecosystem can happen in your virtual and cloud ecosystem. That includes phishing attacks, number one threat vector, still could be the case. So data breaches still can happen. So multi-factor authentication with zero trust, definitely important in a cloud environment. for protecting against, all types of attacks. Still deploying endpoint detection and response technology is still equally important. EDR can run on a virtual environment, a virtual endpoint, I'm sorry. So it can protect your assets. You still can deploy IDSs and IDPSs, email security, again, DLP, endpoint software, all of those things are still important, and you need to deploy those types of things. Kind of talked about this encryption. Key points here is, in your CASB, your cloud access service broker, again, which is like a very smart firewall. You can have policies that says all communications will be encrypted, and so it will be the broker that sets up, basically builds up your secure connections and then tears them down when they're no longer needed. So that means that you're not only your logging in process is secure, but once you get a session, that's a end-to-end encryption and session there. So all policy driven. These CASB service offerings are pretty slick. Microsegmentation is starting to gain some traction here. So this, segmenting software through segmenting your environment through software, through agents that can go out and discover what you have running. You can then set up policies to say, I want to have an HR group. I want to enforce least privileges and role-based access control to these different areas. I want to have a contracts department. I want to have a DevOps deployment. I want to have an operations department. All these things you can kind of create micro segments and manage those segments, and the micro segmentation agents will report to you what's running on all endpoints, what versions of software that's running, operating systems. They can You can pull that data into a scene, which then could help you do vulnerability management, patch management, et cetera. I think I've kind of talked about this private cloud system management. Companies and organizations increasingly shifting to their computer infrastructure to be on-premise, off-premise, and in the cloud. So you have in hybrid environments. That makes it much more complicated. And therefore, you need the skill set that knows about not only native cloud services, but even if you just want to rehost applications in the cloud, how do you do that? How do you rehost a web server and your web applications in the cloud? And then how do you secure them and do access control? How do you do single sign-on in the cloud? How do you use services like Okta to enforce multi-factor authentication and zero trust? That's a lot of what this is talking about. And all these services are available to you on-premise and in the cloud. So next, kind of really kind of queued it up already, but zero trust networks again. Application modernization and zero trust strategies demand modern identity protocols. And the key points here, you still need to deploy technology to secure your perimeter, secure your endpoints, monitor your environment. But because we have so many users that work remote, that use untrusted networks, that like to use their private, you know, mobile devices and laptops, maybe because their machines are faster than what the companies are providing, you have to implement concepts like zero trust. You don't trust any user, any device, any processes um, um, that want to access your IT ecosystem. You authenticate them and you authorize them. And you continually do it. It's not a one-time thing. It's a continuous as they maintain a session to your assets. So that's what these next slides are really all about, that whole concept of zero trust, the history of it. Again, this is the Gartner kind of topical area or approach, whether you're on-prem or in the cloud, the process is the same, that you can provide basic security. And a lot of that starts with the foundation of um, segmentation. Zero trust, the segmentation is big, but good security practice segmentation is big. Segmentation then follows with the concept of least trust and role-based access control. Role-based access control then leads you into multi-factor authentication with zero trust concepts. And once you start there, you get into basic security of secure the perimeter through firewalls or your software gateway, SWG that you see there, controlling remote access, having some networking monitoring, and then having some endpoint monitoring, and then making sure you do things like deploy DDoS protection, email security filtering. Your advanced security pieces you see here is where you can have, firewall as a service, micro segmentation on top of your physical network segmentation. You can deploy um, machine learning through NDR. So that's what you see, that NDR piece there. But just layering on the defense is really the best approach, whether you're on-prem or in the cloud. So zero trust architecture is a paradigm shift to a lot of organizations, at least in the beginning. I think it's starting to catch hold and become a base, standard operating procedure to do multi-factor authentication with zero trust concepts. Now, as a product, it does not exist, even though many vendors market their product as zero trust. You definitely want to verify that. ZTA is based on the concept of assume the network is hostile, replace implicit trust with adaptive access, secure resources, not the network, authenticate users, devices, encrypt all traffic, monitor all traffic, log all interactions. That's really your best definition for what is zero trust. Read that one more time. Assume all network or hostile. So if they're logging in from their house or from Starbucks or Panera, doesn't matter. Consider the network their own hostile. Replace implicit trust with adaptive trust. Secure resources, not the network. Authenticate users and devices. Encrypt all traffic. Monitor all traffic. Log all interactions. Kind of talked about this already. Key parts that help, key technologies and concepts that help you implement zero trust is SASE for sure. Your SASE providers, again, SASE is not a product, it's a concept too. Micro segmentation concept. You can buy products to do micro segmentation. Your configuration management database, your CMDB, again, that's where your clean baselines, the ability to recover back to a clean state, it becomes really important in case you are attacked and you need to recover quickly. Again, another infographic that talks about zero trust. So two key trends in driving towards a secure access, secure edge architecture is organizational data is distributed across different service boundaries. This when you get into maybe a new type of architecture in your cloud environment, so that could lead you down the microservices approach, which have pipelines, and that pipeline could be both internal and external data sources, applications that act on those data sources. Uh, Infrastructure as a service is your strategy, or software as a service as your strategy. To increase the user experience, processing data closer to the user is becoming more prevalent. And not really doing much with the data, making data immutable to allow for scalability and increased scale. So modifying of data is very limited and limited to mostly administrative approaches. So this, another way of saying this is build a lot of dashboards. And dashboard is just for viewing and reporting on. And you do data analysis, but that actual processing of data happens on a big server. This is what AI is going to bring in because the AI, all that processing is going to happen on the server, and just the results will be presented back to you. That's microsegmentation. This just gives you a little bit more on SASE, how it makes determinations if you authorize or not. Again, a lot of things we've talked about in the class, it all comes together in secure access, secure edge technologies. SASE is a framework covering the convergence of network security functions, and products that implement them is listed on this slide. So your SWG, your CASB, your SD-WAN, or things that help implement that. Again, these are just some more examples of secure access, secure edge. Whether you're accessing Netflix from your your office, at a bank or at a library, at home or at an airport, you could be coming through a untrusted network. You hit the SASE edge. This is where you get authenticated. Once you are authenticated, end-to-end encryption is set up. That's your virtual private network. Authorization then happens, which is policy driven. That determines what you're authorized to now gain access to. And that determines if you can actually now go start Netflix, go to the Weather Channel, go out to your Salesforce or CRM or Office products, etc. And that is it. It's cloud migration methodologies and cloud security. Again, good luck on the quiz and good luck on the final. The final is comprehensive. It will cover all topics discussed throughout the semester, both on the midterm, prior to the midterm. Will include term paper topics, so the technologies you're doing your term papers on. Also, understanding attacks, um, incident response, and root cause analysis to determine how attacks were successful. All those things are definitely important. And um, that's it. It's really all the topics. So best of luck. If you have questions, email me or post. I think I'll have one more Wednesday virtual office hours. I'll see you there. Thank you.